Assalamu alaikum warahmatullahi wabarakatuh. I hope that everyone is okay, inshallah ta'ala. So we are going back to um, Physics SAAT Part 2 out of 25 questions, right? So we are going to go through some of the questions remaining from the exam, right? So let's start this one. So question number 9 says the speed of a wave whose frequency is 2 hertz and wavelength is 0.5 meters is, right? So again, a quick review for the speed of waves, right? The formula for speed of waves, that the speed of a wave is equal to frequency times wavelength, simply. And don't forget again that units must be consistent, right? So we are using SI units here. So since that I'm using hertz for frequency and I'm using meters for wavelength, right? So the speed unit should be meter per second, right? So here the speed of a wave whose frequency is 2 hertz and wavelength is 0.5, simply that would be 2 times 0.5. So the answer is 1 meter per second, right? So the answer is A, okay? Now, second question, question 10. The distance a sound covers in 10 seconds when its speed is 340 meters per second is, right? This is another aspect that we can use in order to relate speed of sound to different values, right? Speed of a wave can be found using two formulas, right? So we can use the normal speed formula, which is distance over time, and we can use frequency times lambda, which is wavelength, right? Since that here we don't have frequency or wavelength, right? And he is looking for the distance that the sound would cover, right? So here we're going to use this formula. So in order to get the distance, again, it's equal to speed times time, right? Speed here is 340 meters per second, and it covers it in 10 seconds, right? So it would move for 3,400 meters. So the answer here is C. Next, the mirror that shows an upright, virtual, and smaller image is, right? We have basically three types of mirrors, right? Convex, concave, and plane mirror, right? Okay, a quick review about them. The concave mirror is the mirror where the internal surface is the reflecting surface, right? The convex mirror is the opposite way around. This is where the external surface is the reflecting surface. The plane mirror is the normal mirror, right? That you can see it in your bedroom or in your washroom, right? So which one of them makes upright, virtual, and smaller image, right? Concave mirror, it can make upright, it can make virtual, but in case of a concave mirror, it can make only bigger image, right? On the other hand, as for the convex mirror, it can make upright, and actually this is the only case of a convex mirror, and it makes virtual, and it makes smaller image, right? And as for the third one, for the plane mirror, right, it makes upright, virtual but equal in size objects, right? So in this case, the only option here is A, right? That is the convex mirror. Just a quick review. Upright image means the image is not upside down. It is normally oriented, right? A virtual image is the image that cannot be received on a screen. And the size, as you can see, there are differences between them. So here, the only option is that convex mirror. Light produced in one plane is called, right? Now, light normally is, is produced in two planes, right? But if light somehow is reflected off a non-metallic, if it reflects off a non-metallic shiny surface, it becomes polarized, right? So it moves only in one plane. So the answer here is D, polarized light, right? Question 13, which one of the following factors doesn't affect the rainbow formation, right? Rainbow, as we know, is the dispersion of white light into 7 colors, right? And these colors, in order of increasing frequency, they start from red, orange, yellow, green, blue, indigo, and violet, right? There are 7 spectrum colors. Now, which of the following does not affect the rainbow formation, right? So here we have diffraction, we have reflection, we have scattering, and we have refraction, right? Also, we need to make a quick review about them, right? Diffraction is when the wave passes through a narrow gap, right? So the wave's shape change, the wavelength stays the same, the frequency stays the same, everything stays the same except for the shape of the wave, right? Scattering is when light passes, for example, through a medium, right, from one medium to another medium. So the shorter wavelength light, it scatters more, right? Reflection and refraction, we are commonly knowing them, right? Actually, the only option here that has nothing to do with the rainbow formation by any means is diffraction, right? Whether it is reflection, refraction, or scattering, the three of them, they can participate in the formation of rainbow, right? By any means. But diffraction has nothing to do with the formation of a rainbow. So this is the answer. Next, the electric force between two objects was 360 newtons if the distance between them increases 6 times than before. What is the value of the force between them, right? Again, recalling Coulomb's law of electric force, right? According to Coulomb's law, electric force is equal to Coulomb's constant, Q1, Q2 over R square, where R is the distance between the charges. Q1 and Q2 are the magnitude of the charges, right? This is the value in coulombs, and this is the distance in meters, right? So according to this point, electric force is directly proportional to Q1, Q2, which means that if one of the charges or both of them increases, the electric force, whether it is an attraction or repulsion, would increase as well, right? On the other hand, the electric force is inversely proportional to R squared, right? Which means when R increases by a factor, F decreases by square this factor, right? So let's have a look at this point. The electric force was 360 newtons, right? And the distance increased by 6 times, right? We can write the formula in this way. R goes to 6R. So it increased 6 times, right? Which means that the charges, they moved further apart from each other. So in this case, the electric force F electric, it will decrease, right? by 1/6. But not just 6, because the relationship here is with a square. So it's 1/6 square, right? So the force will decrease by 36 times, right? If the original force was 360, so 360 divided by 36, so the new force would be 10 newtons, okay? So the answer here is A, okay? That's the new force. Next, a capacitor of 2 microfarads has a charge of 120 microcoulombs. What is the potential difference between its plates, right? Now, what relates capacitance with a charge and voltage, right? The formula states that capacitance is equal to charge over potential difference, right? So in order to calculate the potential difference, all what you need to do is to swap them, right? So V is equal to Q over C, right? Which is going to be 120 over 2, right? Now someone might ask, teacher, what about this one, micro? Well, micro is a prefix which means 10 to the power of -6 of the value, right? So here, this brings us to the consistency, like I said before. If both units are using the same prefix, so there is no need to convert them. You can keep them as they are, right, without doing any conversions, because at the end, the prefixes will cancel out. Like here, times 10 to the power of -6 times 10 to the power of -6, right? So the 10 power -6, it cancels with 10 power -6, they cancel out, right? So the answer at the end will be 60 volts. Okay, now for the last question, the total resistance of 5 ohm, 10 ohm, and 20 ohm resistors connected in series is, right? Also a quick review about the connections. In circuits, we have two types of connections. We have series connection and we have parallel connection, right? So when I connect a circuit in series, right, and in order to get the R total, which is sometimes called R equivalent or equivalent resistance, it's equal to the sum of all the resistors, R1 plus R2 plus how many, no matter how many resistors we have, you have to add their resistances all together, right? So here 5 plus 10 plus 20, that gives us 35 ohms, okay? So the answer is A. Hopefully, inshallah, you have enjoyed and you got some benefits from this explanation, this simple explanation for the questions. And see you in the next video, inshallah, which finish the rest of the exam. Thank you for listening. Assalamu alaikum wa rahmatullahi wa barakatuh.